Yeah, my name is Arun Arjunan, and I'm from School of Engineering. I lead the Additive Manufacturing and Functional Materials Research Group. It's a small group within School of Engineering, and we mainly focus on additive manufacturing and developing new materials and structures. So the project that I'm going to talk about is something we sort of refocused ourselves to do when the COVID crisis was going up, and there were some shortages coming up regarding nasopharyngeal swabs. So just to give you some background, so what you are seeing in figure 1 is an example of a nasopharyngeal swab, and these swabs are considered class 1 biomedical devices. And these are quite different from the normal cotton swabs in the sense that you couldn't use any natural materials because the material will interact with the virus that was collected in the swab, and therefore testing cannot be done. So there are only very few companies manufacturing these swabs, and when local lockdowns were coming and shipping and other things were being blocked, there were swab shortages coming. So you can see some reports on figure 2 here regarding swab shortages, and people were trying to solve this problem by various kinds of research. So people were looking at using testing without using swabs, and some groups were trying to develop swabs using another techniques and things like that. So what we tried to do was these swabs that some of the other research groups were developing, they were 3D printed because it could be printed where it is needed rather than the need to be transported. But they were quite uncomfortable during the swab process. The reason for this is one size fits swab. So therefore, the variation in nasal cavity is not considered. So if the swab is used for children or elderly, it will cause serious discomfort, pain, and micro tears, which then causes other infection and other issues. So our group was already working on oxidative materials. So these materials are, you can see in figure 5, quite interesting materials and behave opposite to natural materials. So if you have a natural material or a traditional material, if you compress them, they tend to expand, whereas oxidative materials behaves in the opposite way. So you can see here, if you compress them, they shrink. So in a sense, you can say that these are materials which have negative Poisson's ratio, and when they experience an axial load, they will shrink rather than expand. So this was good for us because we thought if we could conceive a swab head using this principle, when the swab is going through the nasal cavity, when it is experiencing a load, rather than it is putting stress onto the surrounding tissue, it will try to shrink, so therefore there won't be any stress to the tissue. So we started experimenting with different structures that could be 3D printed. We created a numerical model, like you can see in figure 6. We understood the safe load that current traditional swabs can withstand, and then we mimicked the loading condition onto these structures. And we tested different structures. So you can see one of the example here, RE1 is a regular swab, and it expands, whereas all the AX swabs, which are all oxidative swabs, sort of shrinks under the load. So what we did is we selected the best one, and this was quite an interesting problem because one, we wanted to create a safe structure, therefore we don't want it to fail, whereas we wanted a structure which is quite flexible as well. So we had to design it for the right load, maximizing the radial shrinkage. So we created a design of experiments model, and we extracted the parameters that will have significant influence on the kind of responses we wanted. And we used the Box-Benken design to randomize these points. And then we do analysis for the random points, and then we stitch them back together using regression models, using equations. And this will help us to identify where the optimum lies. So for example, if you look at figure 12, you can see that the optimum lies somewhere at the diameter of 0.2 and the angle of 85 degrees. So from this, we can conceive the optimum swab. So using that, we developed the final swab that can be used for testing, for swabbing for COVID testing. And these swab, the interesting thing is that these swab will adjust to any nasal cavity. So these won't try to expand or put any stress on the surrounding tissue. This can automatically self-adjust. So this, we manufactured them in collaboration with Form Labs, who wanted to collaborate with us. And the next stage, what we are trying to do is we are creating a general model where any material can be used to create any biocompatible material can be used to develop these swabs. So this is where we are. Thank you.